All right, so the first thing we're going to do is we're going to take a look at solving linear equations. And I'm going to write down the 6 steps to solve a linear equation. Okay, and the very first step is you want to remove any fractions. Okay, so in this course, when you're solving a when you're solving a linear equation, you're going to encounter fractions. So the first thing you want to do when you're solving a linear equation is you want to remove the fraction, and you remove the fraction by multiplying both sides by the least common denominator, right, the LCD. Okay, the least common denominator is also the same thing as the least common multiple. Okay, so we're actually going to take a look at solving problems that involve all of these steps. Okay, so that's the first step you should do. The second thing you want to do is you want to remove any parentheses, and you remove parentheses by using the distributive property. All right, the third thing you want to do is you want to combine like terms on both sides. Okay, the fourth thing you want to do is you want to use the addition / subtraction property of equality. And the property of equality, it basically states that whatever you add or subtract to one side of your linear equation, you must add or subtract that same quantity from the opposite side. Okay, so in this first part, we're going to solve equations, and an equation contains an equal sign. So that equal sign splits your equation up into two parts, the left-hand side and the right-hand side. So whatever you do to the left-hand side, you must do the exact same thing to the right-hand side. Okay. The fifth thing you want to do is use the multiplication / division property of equality. All right, so here again, whatever you whatever you multiply or divide by one side, you must multiply or divide the other side by that same quantity. And then the sixth step is to check. All right, check your solution. All right, so we're going to use these 6 steps to solve a linear equation. All right, so here is the first example. Okay, so here we just asked to solve 12 minus 4 times the quantity x plus 4 is equal to 3x minus 6. All right. So keep in mind, this is a linear equation. What makes this equation linear is the fact that if we take a look at our variable, and here the only variable is x, our variable x is raised to the first power only. All right, so that constitutes this as a linear equation. Okay, so now we're just going to run through those 6 steps. So the first step says remove any fractions. which we don't have in this equation. The second step says remove any parentheses by using the distributive property. So remember that the distributive property, it states that if we have a set of parentheses, so here I'm looking at the x plus 4 is within the set of parentheses, I'm going to take the number on the outside, in this case, which is -4, and I'm going to multiply or distribute -4 with every term on the inside of the parentheses. All right. So I'm going to bring down 12, and I'm going to distribute -4, so -4 times x is -4x. -4 times a +4 is -16. And I'm going to bring down an equal. And I don't have any parentheses on the right-hand side, so I'm going to bring down 3x minus 6. All right, so we have moved the parentheses. The next step is to combine any like terms. So remember that a like term is the same variable with the same power. So if I look on my left-hand side, notice I have a 12, right, which is a constant. Right, a constant contains no variables. Right, it's just simply a number. That number can be negative. That number can be positive. The number can be a fraction or a decimal. So on the left-hand side, we have two constants, 12 and -16. All right, so I want to combine those two. So 12 minus 16 is -4. And I'm going to bring down -4x. And I'm also going to bring down the right-hand side, 3x minus 6. All right, now once we get to the fourth step, here's something you may or may not want to do. You may want to set a guide. Okay, and what I mean by a guide is I'm going to put this on as V is equal to C. Right, so what this means is that V equals to variables, C equals to constants. So my goal here is to put all my variables on one side and all my constants on the other side. Now, it doesn't really matter if you put your variables on the left-hand side or the right-hand side. Okay, here I'm just choosing to put the variables on the left-hand side. So I just want to look at my equation based upon my guide. So if I look at my guide on the left-hand side, I only want variables. -4 is not a variable, so I'm going to take -4 and I'm going to move it, or I'm going to transpose it to the opposite side. Now, when I say transpose, that simply means when I move one term from one side to the other side, I'm going to change its sign. Right? So I can add 4 to both sides. All right, so I'm going to bring down -4x is equal to 3x minus 6 plus 4. Right, so I transpose -4 from the left-hand side to the right-hand side by simply changing its sign. All right. So now I'm going to simplify. Okay, so I'm going to bring down -4x. On the right-hand side, I have two like terms, -6 and +4. So I'm going to bring down 3x. And -6 plus 4 is -2. All right, so I've simplified the right-hand side. Now, if I go back and take a look at my guide, notice that I have only a variable on the left-hand side, which is what I want, right? Variables on the left. I only want constants on the right-hand side. So if I look at my right-hand side, 3x is not a constant, so I'm going to transpose it or move it to the right-hand side. So I'm going to change its sign. So now I have -4x minus 3x is equal to -2. I'm going to combine like terms on the right-hand side. Negative 4x minus 3x is negative 7x is equal to negative 2. So now I have what I set out to accomplish, right? I have all the variables on the left, constants on the right. However, I want to isolate for my variable x. So once we have the variables on one side and the constants on the other, we want to use the fifth step. In our sixth step, we want to use the multiplication or the division property of equality. So here, in order to isolate x, the opposite of multiplying x by 7 is to divide by, the opposite of multiplying x by negative 7 is to divide by negative 7. So I'm going to put an extra step in. I'm going to divide both sides by negative 7. So on the right-hand side, the negative 7s cancel, and we're left with x. Okay? And keep in mind that x should always be positive. All right, so now if we simplify, a negative divided by a negative is a positive, so we have x is equal to 2/7. So that is the hand solution. All right, now we're going to take a look at using the calculator. And before I get into using this calculator, I'm going to just make this disclaimer. Using the calculator is not a substitute for learning this stuff. Okay, I'm mainly going to use a calculator to check my hand solution. All right, so using a calculator, we're going to use something called the intersect method. So this is the calculator solution, and we're going to use something called the intersect method. Okay, and there's more than one way to actually use a calculator to solve it, but the intersect method, in my opinion, is like the most straightforward method. So here's how I use the intersect method. I want to go into, first of all, I have to turn it on. I'm going to go into y equals, and I'm going to choose y sub 1. I'm just going to clear out the equation that I have in y sub 1. Okay, it should be 3x minus 6. I'm now going to go to calculate, which is second and trace. I want to scroll down to intersect. So let me just write some steps. So the first thing we did was enter the left-hand side as y sub 1 and the right-hand side as y sub 2. The second thing we're going to do is calculate the solution. So we went to second and trace, and I'm going to scroll down to number 5 on my particular calculator, which is intersect, and I'm going to hit enter. Okay, so now it's going to ask you 3 questions. It asks for first curve. So if you look at the top of your calculator, notice that it's on y sub 1, right, which was the first curve we put in. I'm simply going to hit enter. Next, it asks for the second curve. So notice that it has now moved the cursor to the second curve, y sub 2. I'm simply going to hit enter. The third thing is that it asks for a guess. So for guess, I'm going to simply hit enter. All right, and it gives us the solution. Okay, so what it actually gives us is it gives us the ordered pair of the intersection point. However, we only want x. Okay, so here's how we're going to actually pull out the 2 sevens. I'm going to go back to my home screen. So whenever I say home screen, that's the second in the mode, which is this quit key. All right, so notice that it just says x is 0.2857. Oops. That value is actually stored for x. So like if I hit x and if I hit enter, right, that's that 0.287. I can change that to a fraction. So if I were to hit math and the first option in math, it'll attempt to take whatever is given and convert it to a fraction. Notice you should get 2 sevens. All right, so if you don't get a whole number as your, and I'm only concentrating on the x coordinate as a solution. All right, so if you don't get a whole number as the answer, right, you can go back to your home screen. That value is stored as x, right, and you can change that x to a fraction. All right, so let's take a look at another problem. So here we have x plus 2 divided by 3 minus x plus 3 divided by 4 is equal to 1. All right, and we're going to use the 6 steps because this is a linear equation. All right, so first we notice that we see fractions. So the first thing we should do is remove the fraction. Right, so removing a fraction, we need to find the least common denominator. The least common denominator is the same as the least common multiple. All right, so I'm going to explain multiples. So I'm going to write out all the multiples of 3. Right, the multiples of 3 are 3 times 1, which is 3. Okay, 3 times 2, which is 6. 3 times 3, which is 9, 12, 15, and that keeps on going, right? The multiples of 4 are 4, right? 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12, 16, so on and so forth. All right, so the least common denominator, which is the same as the least common multiple, is going to be 12. All right, so we want to multiply both sides by 12. Right, so I'm going to multiply the left-hand side by 12. And the right-hand side by 12. Right, so multiplying by the least common denominator or the least common multiple should clear our fraction. So notice we have a set of parentheses, so we're going to distribute. When we distribute 12 by the first term on the left-hand side, notice that the 12 and the 3, right, 12 divided by 3 reduces to 4. So I actually want to distribute 4 with my first term. All right, so 4 times x is 4x, plus 4 times 2 is 8. All right. So now I'm going to distribute 12 by that second term, right? Right, so notice I reduced the 12 to a 4 because in that first term there was a denominator 3, but I'm actually distributing 12. So if I distribute 12 by my second term, the 12 and the 4 are going to reduce to a 3. So 3 times, and I would also have to distribute this negative, right? So negative 3 times x is negative 3x. Negative 3 times a positive 3 is a negative 9 is equal to 12. Right, so keep in mind, since the second term is negative, you must distribute a negative and a 3. All right, so we have now cleared the equation of any fractions. We don't have any parentheses, so the next thing I'm going to do is combine like terms. So on the left-hand side, I have 2 x variables. All right, so 4x minus 3x is x. I have 2 constants. Right, so notice I'm not changing any signs or anything because these terms are on the same side. 8 minus 9 is a negative 1. Okay, and that's equal to 12. Okay, so we have completed the first 3 steps. We remove the fraction, we remove the parentheses, we combine any like terms. So before I get to the 4th, 5th, and 6th steps, I'm going to set a guide. So for my guide, I'm generally going to put my variables on the left and constants on the right. So on the left-hand side, I only want variables. Negative 1 is not a variable, so I'm going to transpose it to the opposite side. So I'm going to simply add 1 to both sides. So here we have x is equal to 13. All right, so we're going to check by using a calculator. Okay, so I'm going to go back to y equals, and I'm going to just clear out y sub 1 and y sub 2. Well, I'll just go back to. All right, so when I'm putting this in the calculator, the left-hand side, I just want to make sure I use a set of parentheses around my numerator. So I'm going to put in a parenthesis, x plus 2 divided by 3 minus another begin parenthesis, x plus 3. All right, close off my numerator, divided by 4. For y sub 2, I'm going to put in 1. I'm going to graph by using Zoom 6. Now, here's just one thing about using a calculator. In order for the calculator to find a solution, you must see the point of intersection. So keep in mind that this thing is only going out to negative 10 and positive 10. So I'm going to go back into Zoom, and I'm going to scroll down to 0. So Zoom 0 is Zoom fit. So that means it'll actually fit the graph to our screen. Oh my goodness. All right. Okay, so this is why I'm saying the calculator is it's not a substitute for learning this stuff. So I'm gonna go to Zoom 6. I'm gonna go back to Zoom 6. Since we have done the calculation by hand and we know that x is equal to 13, I'm gonna go into Window. I'm gonna change my x max to about 20. Okay, so that's gonna stretch out the graph. Right. So what I did was I just increased the x max to 20, right? Because I know it should intersect at 13. So now if I go into second and traits, which is calculate, I want to calculate the intersection. And I'm basically going to hit enter 3 times. Okay, and notice it gives us the x coordinate as 13. So the solution is only that x coordinate. All right, now we have two other types of solutions that we may deal with. One is called an identity and the other is called a no solution. Okay, the two equations that we just looked at, they both had a single solution, which is a single number that'll make both sides equal. But there are some instances in where any number is a solution, and then there's some instances where there's just no solution. And so we're going to take a look at these special types. All right, so here we're asked to solve 2 times the quantity 2x minus 1 plus x is equal to 5x plus 2. All right. So we're going to use the 6 steps. So we don't have any fractions, but we do have a set of parentheses. So we're going to move the parentheses on the left-hand side by distributing or multiplying by 2. All right, so 2 times 2x is 4x. 2 times negative 1 is negative 2. And I'm going to bring everything else down. I don't have any parentheses, any more parentheses. So the next thing I'm going to do is combine like terms on both sides. So on the left-hand side, we have 2x variables. So 4x plus x is 5x minus 2. And then we have 5x plus 2. All right, so I'm going to put all my variables on one side and my constants on the other. So now something funny is going to happen with this equation. So if I look on my left-hand side, I only want variables. Negative 2 is not a variable, so I'm going to add or transpose negative 2 to both sides. So I have 5x is equal to 5x plus 2 plus 2. And now I'm going to simplify, so I have 5x is equal to 5x plus 4. So I only have variables on the left-hand side, which is what I want. On the right-hand side, I only want constants. All right, so 5x is not a constant, so I'm going to transpose 5x to the opposite side. So I'm going to subtract 5x from both sides. All right, so then I have something that looks like this. 0 is equal to 4. All right, so notice that my variable has zeroed out. Since 0 can never equal to 4, this is a no solution. Okay. And we'll see what the graph looks like in a second. All right, so just notice when I put all my variables on one side and all my constants on the other, I get something that says 0 is equal to 4, which 0 can never equal to 4. So that's an indication of a no solution. All right, so let's look at this example. 2 times 2x minus 1 plus x is equal to 5x plus 2. It looks the same, but it's a little bit different. All right, so if I follow the same steps, I'm going to distribute 2 on the left-hand side. So we have 4x minus Is this the same problem? I'm sorry, this should be a minus 2 over here. Okay, that should be a minus 2. All right, so we have 4x minus 2 plus x, and on the right-hand side, we have 5x minus 2. And then if I simplify my left-hand side, I can combine like terms. 4x plus x is 5x minus 2. So notice I have the exact same thing on both sides, which means that any number I put in would be a solution because one side would make the other side equal. But if I were to set my guide, I would add 2 to both sides, and I would subtract 5x, and I would end up with something that looks like this. 0 equals to 0. This is an identity for all real numbers, which means that every number is a solution to this equation. All right, now if you check these things on a calculator, just zoom out on that a little bit. I'm going to start with this all real number solution first. All right, so I'm going to go back to y equals, and I'm just going to clear those equations out. I'm going to put in the left-hand side, which is 2 parentheses 2x minus 1 plus x. I'm going to put in 5x minus 2. And I'm going to hit zoom 6 to graph. But when you graph, you're only going to see one line. And the reason why you only see one line is because these two things are exactly the same. So if both sides are equal, and if we take a look at this part, when you actually graph, since these two things are the same, one line fits exactly on top of the other line, right? So they intersect at every point, which makes it an all-real solution. If I were to go back into y equals, and I'm going to just change y sub 2 to 5x plus 2, right? If we were to graph here, we're going to see two parallel lines that never intersect. So the only way you can get a solution if they intersect at one spot, which is the two problems we first solved, they only intersected at one spot. The very last problem, since one line fit exactly on top of the other line, they intersected at every spot. And for the no solution, they never intersect at all. All right, so any questions on solving equations? We looked at a couple of ways, by hand and also using the calculator. All right, now the next thing we're going to take a look at is the rectangular coordinate system. And I believe we're done with the calculator. All right, we're going to take a look at the rectangular coordinate system. In some books, you may see it as a Cartesian coordinate system. So for the rectangular coordinate system, we have two axes. We have a horizontal axis, which is the x-axis, and we have a vertical axis, which is the y-axis. So now from geometry, we have what's called a plane, and a plane, it extends forever in all directions. The x and y axes, they split the plane into four quadrants, right? So I'm going to start with the upper rightmost quadrant, and that's quadrant 1. And the quadrants go around in a counterclockwise motion. So quadrant 2 is the upper leftmost, quadrant 3 is the lower leftmost, and quadrant 4 is the lower rightmost. Where these two axes meet, that's called the origin. And the origin has the coordinates 0, 0. You can determine the exact location of any point in this coordinate system by what's called an ordered pair. And an ordered pair is in the form of x, y, where x is the horizontal component and y is the vertical component. So when you plot points, you must always start with the horizontal motion, either left or right, and then that second motion is the vertical component. All right, so we're going to take a look at plotting some points. So we're going to plot the following. We're going to plot point A, which is 3, 2. We're going to plot B, which is -1, 3. We're going to plot point C, which is -2, 3. We're going to plot D, which is 3, -2. We're going to plot point E, which is 4, 0, and point F, which is 0, 4. So I'm just going to use a hand-drawn graph, nothing spectacular or anything. So this is not drawn to scale by any means. All right, so I'm just going to go out to 5 for 1, 2, 3, 4, 5. Okay, I'm just going to go out to 5. All right, and we're just going to plot the points. So we're going to plot point A, which is 3, comma, -2. So when plotting points, you always want to start at the origin. Since x is +3, I'm going to go 3 places to the right. Since my vertical component is +2, I'm going to go up 2, and that is the plot for point A, right? And A is in the first quadrant. I'm next going to plot point B, and it has the coordinates -1, comma 3. So I'm at the origin. My horizontal component is -1, so I'm going to go 1 place to the right. My vertical component is +3, so I'm going to go up 3 units. And this is the plot for point B. All right. And that's in the second quadrant. Next, I'm going to plot point C, right, which is -2, comma, -3. So again, I'm at the origin. Since my horizontal component is -2, I'm going to move 2 places to the left. My vertical component is -3, so I'm going to go down 3 units. And that is the plot for point C. And that's in the third quadrant. Next, we have point D, which is 3, comma, -2. So again, I'm at the origin. My horizontal component is +3, so I'm going to move 3 places to the right. My vertical component is -2, so I'm going to go down 2. And we have point D, which is in the fourth quadrant. And so now we have point E, which is 4, comma, 0. All right, so again, I'm at the origin. My horizontal component is +4, so I'm going to move 4 places to the right. 1, 2, 3, 4. My vertical component is 0, so that means I'm not going to go up. I'm not going to go down. I'm going to stay on the x-axis. And this is what we consider to be an x-intercept. The intercept points lie on the axis. Since this point lies on the x-axis, that's the x-intercept. For any x-intercept, the y-coordinate should always be 0. And we'll talk more about that in just a second. And for our last point F, we have 0, comma, 4. So again, I'm at the origin. Since my horizontal component is 0, that means I'm not going to move to the left and I'm not going to move to the right. I'm going to stay on the axis. Since my y coordinate is 4, I'm going to go up 4. Since the point 0, comma, 4 lies on the y-axis, this is an y-intercept point. So notice that every y-intercept point must have an x-coordinate of 0. Okay, so here's a recap on a rectangular coordinate system and plotting points. So now we're going to talk more about the x and the y intercepts. Oops. Okay, so this is, so find the x and y intercepts. 2x plus 5y is equal to 10. All right, so if I'm given a function, and if I'm asked to find the x and the y intercepts, here is how we should proceed. All right, so we just saw from plotting points, if you're trying to find an x-intercept, right, that point should lie on the x-axis and its y-coordinate should be 0. So I'm actually going to write that out. To find the x-intercept, let y equal 0 and solve for x. And then conversely, to find the y-intercept, we let x equal 0 and solve for y. This is actually a method for graphing a linear equation. You can graph in one of three ways, as we're going to see in this class. You can graph using an x and a y chart, right, where you just take some numbers for x, stick them into your equations, find y. You can graph by this method, which is called the intercept method, right? It's only 2 points, whereas when you use an x and a y chart, you mainly use more than 2 points. You can also graph a linear function by using slope-intercept form. Okay, and we're going to talk about slope-intercept form a little bit later in the class. So for now, we're just finding these intercept points. So we're going to find the x-intercept first. Right, so I'm basically going to take 2x plus 5y is equal to 10, and I'm going to let y equal to 0. Right, and I'm just going to solve it for x. So in the equation, wherever we see a y, we're going to substitute y for 0. Right, so now if we simplify it, so we have 2x, 5 times 0 is 0, so I have 2x is equal to 10. The opposite of multiplying x by 2 is divide by 2, so x is equal to 5. So the x-intercept is 5. Or sometimes you may be asked to write the x-intercept as an ordered pair. So if you were to write that out as an ordered pair, you would have 5, 0. So notice that for the x-intercept, the y-coordinate must be 0. So now we're going to find the x-intercept, the y-intercept. So in order to find the y-intercept, we're going to let x equal to 0. Right, so we're going to take our equation 2 times x, but we're going to substitute x for 0, plus 5y is equal to 10. All right, 2 times 0 is 0, so I'm going to bring down 5y is equal to 10. All right, divide both sides by 5, so y is equal to 2. All right, so the y-intercept is equal to 2, or if you have to write it out in an ordered pair, the ordered pair format is 0, 2. All right, so the next thing on the agenda is is to express the following in terms of x and y. Now, I believe in the homework, it just asks you to express things in terms of x, but we'll do x and y. All right, so we're given this equation, 5x plus 2y is equal to 10. And the first thing we're going to do is we're going to express in terms of x. So what does it mean to express something, or in this case, this equation in terms of x? To express in terms of x, it basically means to solve for y. This is a useful skill because as we go through the course, we're going to use a calculator, we're going to graph some things, and in order to graph, your equation has to be expressed in terms of x, right? Which means you must be able to solve it for y. So we're going to solve 5x plus 2y equal to 10. We're going to solve it for y. So 5x plus 2y equal to 10. So the first thing I'm going to do is I'm just going to locate the side of the equation that contains y. Right, so y is on the left-hand side. Since I've located the side which contains y, right, 2y, I'm going to take 5x, which is totally unrelated to the y term, and I'm going to transpose or move it to the other side. So I have 2y is equal to negative 5x plus 10. Now we want to solve it for y, not for 2y. So the opposite of multiplying y by 2 is to divide by 2. So I'm going to divide everything by 2. So I'm going to just put this step in. So I'm going to divide 2y by 2. I'm going to divide negative 5x by 2 and 10 by 2. So on the left-hand side, the 2's are going to cancel. On the right-hand side, I'm left with 5/2 x, and 10 divided by 2 is 5. So we have expressed the equation in terms of x. Right, so we're going to take that same equation, 5x plus 2y, and in this instance, we're going to express in terms of y. So what does it mean to express in terms of y? Well, that means to solve for x. So I'm just going to rewrite the equation. 5x plus 2y is equal to 10. And I'm going to do the same thing that we did before, but in this case, I'm going to locate the side which contains the x term, right? So x is on the left-hand side. So I'm going to take my y term and I'm going to transpose. I'm going to move it to the other side. I'm going to subtract 2y from both sides. And the last thing I'm going to do is divide everything by 5. So we have x is equal to negative 2/5 y plus 2. All right, so we have expressed in terms of y. Okay, now the last two things we're going to do is we're going to find the distance between 2 points, and we're going to find the midpoint, right, between 2 points. And I just want to, I'm going to bring up that formula sheet. I'm going to go into formula sheets. And I'm going to go into the module 1 formula sheet. Okay. And I just want to point this out. You may see this distance formula written a couple of different ways. On this formula sheet is written out as the square root of x sub 1 minus x sub 2 quantity squared plus y sub 1 minus y sub 2 quantity squared. If you look at the viewing example, it's actually written out as the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. If you take a look at the lecture videos posted by the department chair, she also uses the x sub 2 minus x sub 1. And I point that out because you may see this formula written a couple different ways, but no matter which way you see it written or which way you use it, you should get the same result. Okay. So I just want to point that out because if you're looking at the videos or if you're looking at the viewing example, and then let's say on test day you pull up this formula sheet, and then that might throw a wrench in the whole thing. I thought the formula was different, but the formula may be one or two ways, but either way that you use it, you should get the same result. I just wanted to point that out. So I say that because I'm actually going to use this formula, x sub 1 minus x sub 2 quantity squared plus y sub 1 minus y sub 2 quantity squared. But I just had to point that out because it has come up earlier. So here we're asked to find the distance and the midpoint for the following: -4, -1, and -1, 3. So now you don't actually have to graph this, but I'm just going to draw a hand sketch of what's going on. So I'm going to plot that point, -4, 1. So I'm at the origin. I'm going to go 4 places to the left, and I'm going to go down 1. And then for the second point, I'm at the origin. I'm going to go 1 place to the left, and I'm going to go up 3. So this is our line segment. And we want to find the distance between these 2 points, right? So if I were to actually take a ruler, and if I were to measure from one point to the other point, what is that distance? Okay, in order to find that, we're going to use the distance formula. So the distance formula is the square root of x sub 1 minus x sub 2 quantity squared plus y sub 1 minus y sub 2 quantity squared. All right, so what is y1, y2, x1, and x2? Well, they come from our ordered pair points. So in any ordered pair point, you must have an x, y format. So it doesn't matter which point is your first point or which point is your second point. I'm simply going to use this -4, -1 as my x sub 1, y sub 1. And I'm going to use my second point as x sub 2, y sub 2. Now you could actually use -1, 3 as x1, y1, and you could use the other point as x2, y2, and that's why you may see the formula written different ways. Okay. So now I'm simply going to substitute into the formula. So the distance is equal to the square root of x sub 1, which is -4, minus, right, because there's a minus in the formula, x sub 2, and since x sub 2 is -1, I must make sure that I substitute in a -1, plus y sub 1, which is -1, minus y sub 2, which is 3 quantity squared. So remember from our rules for sign, a double negative is a positive. So I'm just going to go in and I'm going to rewrite this as -4 plus 1 quantity squared plus -1 minus 3 quantity squared. Right, so the only thing I did here was I just made the double negative a positive. So remember, whatever we do in the course, we are using order operations. That please excuse my dear Aunt Sally. So for the please excuse my dear Aunt Sally, the first thing we do is what's in the innermost parentheses. So we made that double negative positive. The next thing we do is we still want to simplify the innermost parentheses. Right? So I'm going to actually keep this square, right, because I'm not squaring anything yet. I'm going to simplify -4 plus 1 is -3. So I have -3 quantity square plus -1 minus 3, which is -4 quantity squared. So I'm going to bring down my equal and bring down my square root. So a -3 times a -3 gives me a +9 plus -4 squared is 16. 9 plus 16 is 25, and the square root of 25 is 5. So that means that the distance between these 2 points should be 5 units. All right, so notice for the distance, we get a single quantity, which is the answer, which is a number. For the midpoint, however, the midpoint is going to give us the coordinates for the middle of our line segment. So here's the formula for the midpoint. We have x sub 1 plus x sub 2 divided by 2, comma, y sub 1 plus y sub 2 divided by 2. Right, so if we were to substitute in those values, x sub 1 was -4, and x sub 2 was is -1. So we have -4 plus a -1 divided by 2, comma, y sub 1 plus y sub 2 divided by 2. So y sub 1 is -1, y sub 2 is +3. So we have -1 plus 3 divided by 2. So if we simplify in the numerator, -4 plus a -1 is -5/2, comma, -1 plus 3 is 2/2. So So we have -5/2, comma 1. So now my graph is not drawn to scale, but that should give me the middle. So negative, I guess if I were to decimalize this, -5/2 is like -2.5, comma 1. So if I go back here, I have, this is -1, this is -2, that's like -2.5. And if I go up 1, oops. Okay, I'm gonna make it fit because it's not drawn to scale. Notice that that should give me the middle, the coordinates for the middle of our line segment.